Hey guys, welcome back. I am going to make a shorter video than I did last time, I promise, over the idea of phase changes. And the reason why we're discussing phase changes is because we're going to be talking about the properties of matter. And when we are talking about properties of matter, one thing we're going to have to notice, obviously, is the state of matter it's in. So we're going to be talking about states of matter. And as you know, there are four total states of matter. There's, as you can see right here, is solid, liquid, gas, and then there's a fourth one called plasma. And of course, plasma is just ionized material like lightning, and it's not as common on Earth as it is throughout the universe. And so our interaction with the day-to-day is minimal. Unless, of course, you're one of those few who've been struck by lightning. Well, then I guess that is a little bit different for you. But for those who haven't been struck by lightning, our interaction with the different phases of matter are primarily on the solid, liquid, and gas. Now, what these phases are referring to is we're just referring to how close the atoms are to each other. That's all it's referring to. So in a solid, the atoms are going to be so close to each other they can't actually move. They're going to just be lined up next to each other so they can't actually move. And because they are so close to each other, they have a definite shape and a definite volume. So a definite shape and a definite volume. Now, shape means it just obviously you can't, it has one shape and it can't change. So it's like a square. Try to take a block, a cube, and then place it into like a graduated cylinder that's too big. Well, it can't fit in there because it can't change its form, and so it's stuck that way. That's for a solid, and for a liquid, as we've read before, a liquid has a definite volume but an indefinite shape. So it can change the shape. It can change shape, but it can't change volume. Meaning, it will take the shape of its container, but it can't spread out past a certain limit. And that's because, like solids, the atoms of a liquid are kind of close to each other. They're closer. They're farther apart than they were as a solid, but they're not so far apart that they can just float away. So they're far enough apart to where they can change their shape, but they're not far enough apart where they can actually take the they can't occupy an entire chamber. So they can't be compressed and they can't be expanded unless you, of course, increase the temperature or increase the pressure. And the final state of matter is the gaseous state, and that is really simply when the particles are so far apart that they obviously can take the shape of the container because they're so far apart, like a liquid, but they can be compressed and they can be expanded so they can float up. So I take a gas and it'll fill up a room. I take a puddle of water and it's stuck on the floor because the particles are close enough to where they can't spread apart. So those are the differences. It's really just how close particles are to each other. Now, as we've discussed in class, though, there are two main factors that affect how close these particles are to each other. There's two main factors, and they are inversely related. So let's get this out over here, and we'll see again how this plays a role. So the two factors that determine whether or not something is a substance of proper or type of matter is its the current pressure, the current pressure, and the temperature. So if temperature increases, so as temperature increases, the particles are moving faster and faster and faster, and so they're actually hitting each other and then bouncing off, and hitting each other and bouncing off, and going farther and farther and farther away from each other. The atoms are literally farther apart, and as we said, the farther it gets away from atoms get from each other, it goes from a solid, then they go farther apart, they're a liquid, go even farther apart, they become a gas. So if you increase temperature, you're going to go from a solid to liquid to a gas. And if you decrease temperature, you're going to go from a gas to a solid to a liquid. The other thing that affects the state of matter is the pressure. And pressure has the opposite effect that increased temperature does. So while temperature makes particles move from each other, increased pressure causes the particles to be forced towards each other, towards the center of each other. And so now the particles are being squeezed together like a compactor because of pressure. And because of that, a gas being squeezed to each other, to the other gas particles, stops becoming a gas and becomes a liquid if there's high enough pressure. A liquid can't really be compressed. That's why it has a definite volume. But if you really, really increase the pressure astronomically, for our sakes, then you can make that into a solid. Now that takes, of course, hydraulics, and the very fact that we have hydraulics means that the force required to do so is crazy high. So that's what determines the state of matter, is if it's a solid, liquid, or gas, and is how close the atoms are to each other. Now, what we can do though is we can go from phase changes. So if the temperature increases, so say I have a solid here, I have a solid, and I want you to look at my color-coded chart. So, and it's color-coded based off what we have. So I have a solid to a liquid. If my temperature increases, my particles are going to get farther apart. That means they're going to go from the solid phase to a liquid phase. That's called I apologize. It's called melting. So when it goes from solid to liquid, it's melting. So if the temperature increases, it's melting. Also, if the pressure decreases, so the pressure holding the particles closer together decreases, that also is melting. The reverse is freezing. These are common everyday terms that we are familiar with. So if the temperature decreases, where the particles aren't moving away from each other, it's a solid. It becomes more of a solid. So think about the easiest thing for this is water, for our sake. In water, when I freeze water, the molecules are not moving away from each other, becoming closer to each other. Well, actually they form kind of a crystal lattice structure, which allows it to become less dense than the liquid water, which is unique with water and pretty cool. But it becomes fixed and rigid, and the particles aren't moving away. So now it becomes a solid from a liquid to a solid. That's called freezing. So if temperature decreases, then it becomes a liquid to a solid. But also, if pressure increases, it becomes a liquid to a solid. So we got the liquid to a solid and solid to liquid check. The next thing is a liquid to a gas or a gas to a liquid. And so solid to liquid and liquid to gas we're familiar with because we see that all the time. So if I continue to increase the temperature and increase the temperature and increase the temperature, I'm going to take something that was originally a solid and turn it into a liquid, increase the temperature, and make it a gas. Because now the particles are so far apart that they can fill up a room, and it doesn't have a definite volume. Now remember, guys, when I say a definite volume, think of water filling up a cup or a graduated cylinder. I pour in my waters, and it goes up to this little range right here, and I can read, oh, that's the volume of it. But if it were a gas, it would just float out, and I couldn't measure it because the volume is going to change because it can be either squeezed together to a tighter or let out and take the shape of the room or fill up the room and has no volume. That's what I mean by volume. And so if I increase the temperature even more, the volume of it also increases, and so it becomes from a liquid to a gas. Like I said, though, I don't have just to increase the temperature, I can also decrease the pressure. So again, if I decrease the pressure, the particles are moving away from each other just as if I would if I increase the temperature. And that goes from a liquid to a gas. If we want to think about that, we can think about boiling of water. So if I'm on a mountain, do you think it'd be easier or harder to boil water on the top of a mountain? Well, the mountain has less pressure on it versus sea level right here, where I have all this pressure of the air pushing down on it. So there's more pressure keeping the water particles closer together. Well, if I'm boiling water in the mountain, it won't take as long to boil, or it won't have to get as hot to boil because there's less pressure keeping the molecules intact. So there's a real life example of that. So again, from a liquid to a solid, from a liquid to a gas, is going to be evaporation, as you see the red with the red. And from a gas back to liquid is called condensation. So, and those are things that we're aware of. So if I decrease the temperature, I'm going to take something that was a gas and I'm going to turn it back into a liquid. Or if I increase the pressure, I'm going to take something that was a gas and I'm going to force those particles closer together and make it a liquid. Now the two hard ones, and two hard ones to remember, are deposition and sublimation. When I go from a solid straight to a gas, that's going to be sublimation. And when we think about this, we usually think of something like dry ice or the ice on top of a mountain where there's a whole lot less pressure and it can just go from solid straight to gas. So dry ice is the most common. So we have the dry ice, and it comes in a block, and then it doesn't really form a liquid. Yeah, there are some puddles forming, but it goes straight to a gas, straight to gas. That's called sublimation. Now I'm kind of in a gas form. The opposite of a gas straight to a solid is solid straight to solid straight to a gas is gas straight to a solid, and that's called deposition. Then again, I guess the easiest one is with water, but and and so that one's just a little bit confusing too, just because we don't often actually come into much contact or so, or much experience with deposition. But just know, so the six terms that you need to be aware of are the six terms are melting, freezing, condensation, evaporation, deposition, and sublimation. Now, and these are all properties of water, and so when I'm saying that, I want you to be aware that when we're about to discuss properties of, or these not water, sorry, properties of matter, when we start getting to describing matter, we're going to be talking about its melting point, its freezing point, its where it is on its triple point or so on a phase diagram. We're going to be talking about those ideas. Anyway, thank you, and if you have any questions, of course, come see me after class.